If your dog's bark had something surprisingly important to say about playfulness, fear, or a late-night intruder that you never expected?
Imagine your cat complaining loudly about dinner time, with actual data behind those meows and subtle whisker twitches to prove its case.
From thousands of barks and nearly 3,000 meow clips, AI models are steadily learning the hidden patterns behind them.
Before you ask a parrot for gossip, let's explore what today's systems can actually infer and what remains guesswork.
Welcome back to our channel, where we decode the language of nature to bring you closer to your furry friends.
Today, we're diving into AI tools that claim to translate barks and meows into human understanding, starting with what science shows.
We'll lay out what the science actually shows, bust some myths, and share stories from pioneers and everyday owners.
We'll also be transparent. Yes, our voices are generated to protect wildlife habitats while still telling rich stories.
Throughout this episode, watch for sources pinned in the panel and mini questions to help you think like researchers.
By the end, you'll know what apps can do, what signals matter, and where this field is headed.
Humans have always imagined chatting with animals, but until recently, our guesses were based on intuition and playful anecdotes. AI research is changing that by collecting thousands of barks and meows across breeds, ages, and contexts, building a richer vocal dataset. One group from Michigan gathered barks from 74 dogs and fine-tuned speech models like Wave2Vec2 to listen more attentively. Their system could recognize play, guarding, or rest states better than models trained from scratch, which is encouraging. On the feline side, Cat Sound and the University of Milan recorded meows in contexts like waiting for food or isolation. These cat datasets include around 3,000 clips and achieve classification accuracy between 91 and 96%. How do machines interpret sound? They transform barks and meows into spectrograms using short-time Fourier or Mel-Cepstral methods. Convolutional networks, or self-supervised speech models, then learn features, distinguishing low, rapid barks from high, playful squeals, and everything in between. Recently, researchers have even repurposed human speech embeddings to improve recognition of dog breeds and gender across different contexts and environments. Beyond classification, some systems map sound features to emotions, linking high-pitched repeating barks to excitement and low, sustained ones to fear. An image for your mind. A spectrogram looks like a colorful landscape where patterns reveal a dog's mood. Some teams even use vision transformers on spectrograms, treating them like images to classify cats' meows more accurately. If your head is spinning, here's the idea. Collect sounds, turn them into visuals, and let AI find patterns. But who is speaking? Models attempt to classify identity, breed, age, and context using pipelines processing thousands of barks. A 2024 study analyzed nearly 19,600 barks to predict the age, sex, and situational context of each dog. They achieved high accuracy, but caution that these models are still prototypes, not ready for everyday translation in consumer devices. On the cat side, meows have been classified into 10 categories using ensemble algorithms with similar performance to canine models. Beyond pure audio, many apps integrate camera data to interpret ear positions, tail wags, and facial expressions for context. Inspired by human facts, researchers created DogFACS and CatFACS systems that code ear, eye, and mouth movements precisely. Dogs under stress, like New Year's Eve fireworks, show ear retraction and open mouths, while flat-faced breeds move less. Cats' faces have also been mapped using 48 landmarks, leading to systems detecting post-surgery pain with over 70% accuracy. Wearable collars now include microphones, accelerometers, and heart sensors to infer mood and alert owners when something's off. One design described by Dataroot Labs can even synthesize a pet's voice for two-way communication with its human companion. A patent from Baidu imagines devices that combine vocal signals, body language, and biological data to translate emotion. Commercial apps like MeowTalk and Furlingo record your pet, compare it with large datasets, and return probabilities for different intents. Reviewers caution that these translations are rough categories, like hunger or play, not full sentences, so manage expectations. Personalization features let you correct the app, but that feedback can introduce your own bias into the model. So far, devices provide alerts and broad emotion categories. Full conversations remain far off for now, though research continues. In the next section, we dive into data deeper and bust some myths about what these tools can deliver. But before we get technical, share in the comments what you wish your pet could tell you in your daily life.
Let's start with the numbers. Dogs have around 19,000 barks recorded, and cats about 3,000 meows collected so far. That may sound huge, but compared to human speech datasets, it's tiny. More data means better models and fewer misinterpretations. Self-supervised models, like Wave2Vec2, can learn from unlabeled audio, yet they still need labeled examples to map emotions. In practice, the system identifies patterns like high pitch and repetition as excitement, but it doesn't understand context. Researchers caution against anthropomorphism. Assigning "I love you" to a bark oversimplifies complex canine motivations and emotional nuance. Meanwhile, classification tasks like identifying age or breed show promise but are far from flawless, especially with diverse dogs. Why the caution? Because dogs vocalize differently depending on context, play, aggression, hunger or fear, and situation. So one bark isn't universal. Breeds matter too. Brachycephalic dogs have flatter faces that reduce facial dynamics, confusing generic emotion detectors, and sometimes leading to misclassification. Even the same dog might bark differently when playing in the yard versus protecting the house or seeking attention. Cat meows show similar variation. High squeaks can mean annoyance or play, depending on tail and ear posture. This brings up an important principle. Audio alone rarely suffices. Combining body language cues improves predictions significantly and reduces errors. Smart collars and apps are moving in that direction, using cameras to track ears, tails, and even heart rate. One prototype collar synthesizes your dog's voice into a human-like message when certain patterns occur to alert you. Sounds enticing, right? Reality check. Accuracy remains modest, and false positives can annoy both pet and owner, leading to frustration. Apps like MeowTalk boast datasets with hundreds of millions of vocalizations, yet rely on user labels that may be wrong. When you correct the translation, you could be teaching the model your assumption rather than your cat's intent. Some bloggers and companies market these apps as entertainment, and that's fine, but treat them like mood rings. So, what passes the smell test? We look for peer-reviewed studies, large open datasets, and transparent methods before endorsing any tool. For example, the University of Milan team published results showing 96% accuracy on meow contexts, but with limited breeds. Another peer-reviewed study on dogs processed nearly 20,000 barks with a pipeline of pre-processing and representation learning. Those studies caution that classification accuracy does not equal translation. Outputs are probabilities, not sentences or clear messages. Now, let's myth-bust a popular claim. My collar speaks for my dog. At best, it estimates mood categories. Manufacturers sometimes advertise two-way communication, but synthesizing a human-like voice for your pet is essentially ventriloquism and not true dialogue. Another myth is that these systems can decode complete sentences. In reality, they classify patterns into predefined buckets. A quick recap. Data volume remains small. Models classify patterns, not language, and context and breed matter for interpretation. Do these limitations mean we should give up? No. Progress is accelerating, and understanding what's possible prevents disappointment and fosters hope. For context, whales, elephants, and crows have much more complex call structures than pets. Yet AI is making strides. Projects like Earth Species Project train large audio language models across species, leveraging patterns learned from human speech to decode animal communication. They've observed positive transfer. Representations learned for human vowels help classify whale codas or bird chirps and reveal unexpected similarities. Project CETI, is compiling huge datasets of sperm whale clicks and training models to identify phonetic-like units and social calls. Such research reminds us that animal communication has its own grammar. We can't assume direct human equivalence, so caution is vital. Ethical concerns also loom. Constant recording may invade privacy and stress animals. Synthetic playbacks could disrupt animal culture and relationships. Developers must design safeguards, including strong data protection and limiting experiments to captive populations with oversight and welfare protocols. Another caution: user feedback in apps often biases the model toward human interpretations, reinforcing misinterpretations and anthropocentric views. Data bias is real. Most recordings come from certain regions or breeds, leaving out diverse voices and unique dialects. Privacy matters too. Recording your home continuously raises questions about who listens, who stores, who profits, and whether consent exists. Finally, there's the risk of overselling. When companies promise talking pets, they may erode trust in genuine progress. Micro recap: treat AI translators as mood indicators, support open science, and always read the method section before trusting results. Here's a viewer prompt. Have you tried any Bark or Meow translator? Comment with your experience and the app used. Pause to open the sources panel if you want to verify these studies. We've pinned them for easy access. After this data deluge, let's shift gears. Our debate will unpack hope and skepticism in a conversational way. We'll challenge each other's assumptions, respond to your questions, and find common ground on the future of pet translation. Don't forget, if you enjoy this deep dive, please like the video to help more curious people find it. We'll continue to update our analysis as new studies appear, so subscribe for future breakdowns and share them with you. Ready for the debate? Grab a notebook or just lean back. The next segment is interactive and full of surprises. After hearing those numbers, my cautious side wonders whether we risk over-interpreting patterns. Does a high-pitched bark always mean excitement? Or could context shift meaning entirely? I worry pet owners may anthropomorphize and misread signals if we aren't clear.
That's a fair concern, and I feel it too. But I'm excited by the idea that these systems can at least tell us when our animals are stressed or happy, giving us a chance to respond compassionately.
Right, as long as we ground expectations realistically. Another worry is that a false alert from a collar might cause anxiety or unnecessary vet visits. Solid evidence should guide how we integrate these tools into welfare decisions.
Absolutely. And that's why I love the community science angle. By sharing more recordings, viewers can help build robust datasets, and along the way, we get glimpses into animals' inner worlds and personal stories that surprise us.
A community dataset would certainly help mitigate bias. Just make sure we have consent and ethical oversight, because uploading home videos can raise privacy questions. It also improves representation across breeds, ages, and contexts, improving generalization.
Totally. Transparency is key for trust. We'll pin the ethics guidelines we follow in the sources panel so you can pause and read them carefully. And we encourage respectful discussion in the comments, always valuing thoughtful community perspectives.
Another angle I want to explore is cross-species translation. Human speech models transferring to whales sounds promising, but can we really expect a universal animal dictionary? Every species has its own ecology and social structure that shapes signals.
I don't expect a Rosetta Stone, but I do think patterns exist. It reminds me of how dialects in human languages reveal environment and culture. And animals are no different, really. And that complexity excites me.
Fair enough. One caution is that replicating whale or bird calls for playback experiments could alter their cultures. Ethical research demands careful boundaries. This is why some projects work only with captive populations until the impacts are understood.
And I'm glad you raised that. Our viewers often ask whether we should play Meow translations back to our cats. I'd say listen more than you speak, and consult behavioral experts before using playback. It's about respect.
I appreciate that perspective. For me, the most exciting part is that AI can highlight patterns we never noticed, like subtle ear twitches signaling discomfort. These insights may prompt earlier veterinary care and improve welfare and deepen empathy.
Exactly. It's less about having a chatty dog and more about empathy. Knowing when your cat is in pain or your dog is anxious could transform how we care for them, strengthen our bond, and create trust.
Let's invite our viewers into this debate. In the comments, tell us whether you lean toward cautious skepticism or enthusiastic optimism about pet translation technology. We'll feature a poll with options and discuss the results in a future video.
Before we wrap this debate, a quick myth to bust together. The idea that animals can't have complex communication because they don't make tools. Our last episode's dolphin discussion shows environment matters more than intellect and learning.
Agreed. And that's a perfect segue. In our next chapter, we'll explore real case studies, from collars on dogs to cross-species whale models, highlighting successes and setbacks in depth. Don't go anywhere. More surprises await you all.
Let's examine some real tools you might have seen advertised. Furlingo and Pet Talk record your pet's bark or meow, analyze the pitch, frequency, and duration, and then match it to a small set of categories like hunger or play. Some versions even use your phone's camera to combine tail wagging and ear position, and they include social feeds so you can share translations with friends and laugh together. MeowTalk deserves special mention because it claims to learn over time. The app uses a database of more than 260 million cat vocalizations labeled by veterinarians to categorize meows into intents such as hunger, pain, or affection. Users can correct the output, which personalizes the model, but also introduces bias. Reviewers note the translations are still rough approximations rather than nuanced sentences, and it's clearly a work in progress. A different approach comes from Dataroot Labs, whose prototype collar houses microphones, inertial sensors, and heart rate monitors. It listens for bark patterns, senses whether your dog is running or resting, and even measures physiological signals. When a specific combination suggests excitement or distress, the collar can synthesize a short spoken message through a tiny speaker, letting owners know their dog's likely mood. However, these devices currently misfire and sometimes misinterpret normal play as an alert. China's tech giant Baidu filed a patent envisioning a smart translator that combines vocal signals, body language, and biological indicators to infer an animal's emotional state. The patent describes using sensors to capture heart rate and movement alongside audio, then feeding this multimodal data into machine learning algorithms. It even suggests synthesizing human speech as output, which raises both excitement about two-way communication and concern about misrepresenting animal intentions and privacy. Beyond audio, facial action coding systems provide another lens. DogFACS and CatFACS break down ear twitches, eye blinks, and jaw movements into standardized action units. When researchers applied these frameworks to video, they found that dogs with short snouts displayed fewer movements across contexts compared to long-nosed breeds. This morphological influence underscores why a one-size-fits-all model struggles and highlights the need for breed-specific training and tailored solutions that respect diversity. The DogFLW dataset, released in 2025, comprises over 3,700 dog images, annotated with 46 facial landmarks. Researchers use these landmarks to build benchmark models for emotion recognition and to classify DogFACS action units. Their video-based study during New Year's Eve fireworks revealed that ear retraction and mouth opening reliably distinguished fearful dogs from relaxed ones, while flat-faced breeds exhibited muted expressions, illustrating morphological impacts. On the feline side, automated pain detection systems use 48 landmarks to track subtle changes in a cat's face. A 2024 study reported over 70% accuracy when analyzing video sequences rather than single frames. The improvement comes from capturing temporal dynamics, such as how the ears slowly flatten and the eyes narrow. These advances could help veterinarians spot discomfort earlier, improving welfare and highlighting potential for telemedicine. Generative models add another twist. In 2025, Researchers fed GPT-4 text descriptions of dog images and asked the model to infer emotional labels. They achieved roughly 76% accuracy on dog photos after careful prompt tuning, which is impressive for a system not designed for animals. However, accuracy dropped on mixed species, and the model often reflected biases present in its training data. This shows generative AI may assist, but not replace specialized approaches. Moving beyond pets, the Earth Species Project trains large audio language models across many species, from crows to elephants. Their research demonstrates that representations learned from human speech can transfer to animal communications, hinting at shared structures. Project CETI focuses specifically on sperm whales, compiling vast datasets of clicks and identifying phonetic-like units. Together, these projects signal that decoding non-human languages may be possible with enough context and collaboration. Cross-species tools like DeepSqueak decode ultrasonic mouse vocalizations for neuroscience, and AI systems recognize rodent alarm calls, proving that translation isn't limited to cats and dogs. While these breakthroughs inspire hope, they also underscore the need for context. Each species has unique signals shaped by ecology and social structure. Any future universal translator will require massive, diverse datasets and careful ethical stewardship to avoid harming the animals we hope to understand. Earlier this month, a viewer from Gippsland offered to send us photos of mysterious footprints that they hoped were evidence of a surviving Tasmanian tiger. We love the enthusiasm. We explained that extra toes often result from double-registered steps, dew claws, or splayed prints in soft ground. If you're curious, please include time codes, locations, and any context when sharing evidence, so we can help verify together and learn from the process.
Another commenter raised an important debate. What happens when we bring back extinct species? They worried that reintroduced animals could behave like invasives and proposed reactivating dormant genes in descendants like chickens to recreate dodos and maybe dinosaurs. We responded by outlining germ cell editing versus gene activation, asking whether success should be measured by the first hatchling, a stable captive line, or a thriving wild population.
We were thrilled when several of you praised our presentation on dodo de-extinction. One viewer thanked us for the balanced breakdown of chicken surrogacy, reality checks on first hatchlings, and rewilding guardrails. We turned the question back, asking which segment resonated most and why. Those reflections help us improve our storytelling, and they genuinely encourage us to grow. Remember, your feedback shapes our pack's future adventures, so keep sharing.
Speaking of community wisdom, one longtime supporter reminded us that beavers are the original ecosystem engineers and suggested we pair our pig-powered desert greening episode with a beaver dam deep dive. We loved that idea and asked for more beaver projects to feature. Such suggestions spark new narratives and show that our pack includes engineers, dreamers, and environmentalists, with projects big and small. Drop your own project ideas below.
We also had a playful exchange with a viewer dreaming of using AI to talk to Phalanux, a lesser-known carnivore. We joked that snacks would be safe, but gently reminded everyone about the ethics of playback and the importance of listening before speaking. That led to a lively thread about which species we should decode next. Do you want to hear from pangolins, otters, or maybe even jellyfish?
Finally, a philosophical comment asked why dolphins, despite their intelligence, never develop technology. We responded that physical constraints, environmental conditions, and different incentives matter more than raw cognition. And we invited a poll. Which factor matters most? Environment, incentives, cognition, or our very definition of technology? The results were split, sparking curiosity. It's an example of how this pack wrestles with big questions while staying playful and humble. Looking ahead, decoding animal communication will demand bigger, richer datasets collected across breeds, ages, environments, and cultures. So citizen science is critical. Your recordings could fill gaps that researchers can't access. capturing differences and voices. Cross-species foundation models like NatureLM Audio hint that large language models trained on human speech can transfer to whales, elephants, and birds. Building dedicated bioacoustic models may unlock shared structures and reveal new possibilities for understanding communication. Smart collars and home assistants will likely integrate multimodal sensors, time of day, and individual history to provide real-time emotional insights. However, designers must protect privacy, avoid stress, and maintain consent by designing with welfare first. Generative AI might one day help us imagine animal expressions we haven't observed, but caution is needed because synthetic playbacks could alter behavior and culture. Ethical guidelines and pilot studies with captive animals are essential. Researchers call for international collaborations to collect cross-cultural data, because a Labrador in Texas and a village dog in Ethiopia might speak very different dialects. Better representation will reduce bias and improve translation dramatically. As we broaden our horizons, it's important to remember animals communicate for their own purposes, not just to entertain us. Humility should guide our curiosity. Respecting their autonomy ensures our work supports welfare and authenticity. In the coming years, we expect regulations to emerge around animal data privacy and playback ethics, much like human data laws. Staying informed will help us advocate responsibly and protect our pets and wildlife. Finally, hope. By combining sound, physiology, and behavior in multimodal models, we can better understand pets' needs, improve their welfare, and even inform conservation for wildlife species, creating a kinder world for all, together. Key takeaway: current AI tools classify patterns and moods, not full sentences, so use them to empathize, not to make decisions or diagnoses. Keep recording and sharing your pet's sounds and behavior for citizen science. Your contributions help build diverse, ethical datasets and inspire others to join. We invite you to like, subscribe, and ring the bell. More deep dives and micro debates are coming, and we want you in the pack. Above all, remember that listening to animals with humility can strengthen the bond between species and inspire conservation for all creatures for generations.